Okay, welcome to my unit called Mission to Mars. It's a grade 6 space unit. I've used Google Slides to sort of contain the unit and put it in my Google Classroom so kids could explore it and to whatever degree possible use it as a kind of model for flipped learning or blended learning. So the unit offers 4 main areas of choice that students can look at: designing a spacesuit, designing a 3D printed tool or a 3D tool, designing a robotic attachment for the EV3 Lego system, or designing a shelter that would be appropriate for life on Mars. So to kind of enter into the general discussion, we had already had some whole class discussions on some of the atmospheric conditions on Mars, talked about gravity on Mars, watched a couple of NASA videos before we even launched the unit itself. Once they had a basic understanding of some of the key concepts and some of the differences you might experience in terms of life in space, specifically life on Mars, we were able to kind of look more specifically on how we might solve problems for an eventual colony on Mars and what that could look like. So under Design a Spacesuit, we do a Minds On with some videos looking at some different approaches to spacesuits over the years and some different diagrams as well, and launch a design challenge. Basically challenging kids to design their own spacesuit, thinking about certain design criteria and showing evidence that they have some research and evidence that they understand, what are the types of forces that a spacesuit in Mars might have to be able to withstand to allow people to live their lives and do their jobs on Mars. So they had to prototype some ideas. They had the option of doing a labeled 3D model or a drawing of their suit and prototype it in any number of ways, including just taking something like a painter suit and adding parts to it, sort of out of cardboard and tape, and just sort of prototyping ideas around how they might design their suit. Another part of this, or another one of the choices that was offered, was to design a 3D tool. We're lucky in our classroom, we have a 3D printer, and I recognize not everyone's going to have that. However, there are different ways you might approach this in terms of tool design. Does not have to be 3D printed. You can build a tool out of any number of types of materials and even a working tool. So the one that I focused on was the particular ratchet that was part of a sort of NASA space station experiment in which a 3D printed ratchet was printed in the space station, and there's a video that we look at that sort of looks at all the sort of issues that might arise when trying to 3D print in space, particularly the impact of microgravity on space. Microgravity on 3D printers in space. So the design of the 3D tool is actually pretty straightforward. This is more of a step-by-step, but there's a lot of parts to this design tutorial that does require you to learn a bit about the software. I used 123D Design as the software of choice for this particular project. It's free, it's available, and quite easy to put on your computers, and even usually board computers if you have that ability to install software. Another one we looked at was to design a robotic attachment. And in doing that, we were taking advantage of the fact that we did have EV3 systems in our classroom. You don't have to use the EV3. What I like about it is that it offers kids also an experience with coding that they might not otherwise have access to. So the nice thing about the EV3 is you can use coding to control the robot to serve or do certain functions. In this case, to deal with a Mars terrain that we kind of co-constructed in the classroom out of bits of insulation, and made a little map of terrain that the robots could try and traverse, and working on the problem that different types of terrain might require a rover to do different types of things, or conversely thinking about permanent vehicles on Mars if we were there as a colony, and what they would need to be able to do to get us around and do our job. So I'm not going to read the parts of the the unit, you can kind of look at those on your own. The other one I wanted to focus on was looking at kind of more the social aspects of designing a home on Mars and what that might look like. Obviously, we don't have a real sense of what that's going to look like yet, but certainly there's a lot of visualizations out there. So this is another one where you could use a 3D printer as your resource. We looked at some videos of 3D printed houses and 3D printing technology being used on Earth to help us rapidly create houses, and how we might apply, again, that kind of technology and in an environment where there's microgravity, how that might change the process for 3D printing in space. Giving kids the ability to kind of prototype, it could be with cardboard. We had the 3D printer, but there's different ways you might go about that. So that is just the unit in a nutshell. I've put a copy of it in my on my Steo Connects Catalyst. Hope you enjoyed. If you have any questions, please connect with me on Twitter. My handle is @GilbertSJ, and I hope you enjoyed. Thank you very much.